183 fires at the same time, inside the same report. But the flames were not the beginning. The real trigger had been building for weeks, hidden inside weather charts most people never stopped to read. It was the sharp collapse of humidity. It was drought spreading across the map at a record pace. It was snowpack disappearing faster than normal across the mountains of the West. And it was a national fire response system quietly moving into elevated readiness before the public fully understood the scale of the threat. We tend to fear the red glow of fire on the horizon. But the most dangerous disasters do not always erupt in a single afternoon. They are prepared slowly through extreme shifts in the atmosphere, through soil losing moisture day after day, and through an entire landscape being stripped of its natural defenses. By the time the wind arrived, the fuel was already waiting. From a distance, a fire outbreak can look simple. Dry grass, strong wind, low humidity, and one ignition source may seem like enough to explain what happened. But that explanation only touches the surface. The deeper question is why so many separate fires were able to ignite across such a wide region at nearly the same time. That is why American Sky Brief does not only look at where the flames are burning, we trace the signals that appeared before them, from the drought map to the shrinking snowpack to the national preparedness level to the dry wind forecasts, to understand when the entire system first began to tilt out of balance. Because fires do not begin when flames appear on camera. They begin when the land loses its ability to resist ignition. That loss can happen quietly over weeks or months. Soil dries out, old grass stays cured, spring green up, weakens reservoirs, receive less runoff, and the atmosphere begins to treat ordinary sparks like active threats. So this is not a story about April 22nd as one isolated shock. It is a story about how April 22nd revealed a system that was already running hot. The most visible number was 183 fires in one day. That number is dramatic, but its real meaning comes from the conditions around it. 183 fires in a single operational period means the ignition problem was not local. It means the fire environment was active across a broad corridor of the central and western United States. The pattern stretched across parts of the high plains and the southern plains. Colorado, Nebraska, Kansas, Oklahoma, South Dakota, New Mexico, and the Texas Panhandle were all part of the larger fire weather setup. That widespread matters because it rules out one simple explanation. This was not one county, one accident, one lightning storm, or one local failure. It was a regional atmosphere sitting over fuels that were already dry enough to respond. When that happens, separate ignition sources can produce separate fires across hundreds of miles. The reported fire count also needs to be understood carefully. It is a confirmed operational number, not necessarily a perfect count of every small ignition that occurred. Some fires may have been stopped by local crews before reaching broader reporting systems. Others may have started outside the reporting window and appeared later in a different operational period. That does not weaken the signal. It makes the signal more important because the confirmed number alone was already large enough to show a widespread ignition environment. The weather conditions explain why ordinary ignition sources became dangerous. In parts of Nebraska, humidity fell near 10%, while wind gusts reached around 50 miles per hour. Those numbers are not just uncomfortable outdoor weather. They are the kind of conditions that allow fine fuels to ignite quickly and carry flame faster than crews can safely contain. Fine fuels are the small materials that respond fastest to the atmosphere. Grass crop residue, dry leaves, brush, roadside vegetation, and small twigs can lose moisture quickly when humidity collapses. That is why grassland fire risk can change faster than many people realize. A landscape that looks unchanged to a driver can become far more flammable within hours of dry wind. The Storm Prediction Center's critical fire weather designation was not casual language. It meant the atmosphere and fuels could support rapid fire growth if ignitions occurred. Critical does not mean every field will burn. It means any fire that starts has a higher chance of moving quickly, spotting ahead, and becoming difficult to control. This is one of the most important distinctions for viewers. A fire weather outlook is not a prediction that flames will appear everywhere on the map. It is a statement about potential behavior once ignition happens. The danger is conditional, but that condition can be met by something as small as a spark from equipment, a downed power line, or a chain dragging behind a trailer. A red flag warning carries the same practical meaning. It does not protect a community, and it does not place resources on every road. It tells the public and emergency managers that the environment is ready for extreme fire behavior. Once the warning is active, prevention becomes more important than reaction. The national preparedness level adds another layer to the story. The country had already moved into level 2 readiness weeks before the 183 fire day. That matters because level 2 means fire activity is already building across multiple geographic areas. It does not mean the entire system is overwhelmed, but it does mean resources are being watched, moved, and coordinated more carefully. The timing changes the meaning of the outbreak. If level 2 had been reached after April 22nd, the fire day might look like the trigger. Instead, the elevated readiness came earlier. That means April 22nd was part of a curve, not the beginning of the curve. The same is true for large fires already burning before the outbreak. Earlier situation reports showed uncontained large fires and hundreds of personnel already committed. That creates an operational problem headlines often miss. A system already managing large incidents has less slack when a new wave of ignitions arrives. Fire response depends heavily on timing. The first hour can decide whether a grass fire stays local or becomes a multi-county emergency. When wind is strong and humidity is low, that first hour becomes even shorter. A fire can grow from a small roadside ignition into a fast-moving front before aircraft or regional crews can arrive. The public often imagines suppression as the main story. In conditions like these, prevention and early detection may matter even more. That is because no response system can be everywhere at once. When dozens or hundreds of ignitions occur across multiple states, the question is not only how strong the response is, but how many places need help at the same time. So the event was not just many fires, it was many fires appearing in an environment where each one had a greater chance of escaping initial attack. That is the practical meaning of the April 22nd number. It showed that the ignition load and the fire weather were rising together. The first driver behind the fire environment was not wind. It was the moisture deficit that existed before the wind arrived. According to the source materials, 61% of the lower 48 was in drought around mid-April. That figure is described as the highest early spring drought coverage in the US. Drought Monitor's 6-year record. The early spring timing is the key. Drought in August is dangerous, but drought at this scale in April changes the entire seasonal starting point. Spring is normally when parts of the plains and west recover some moisture. Rain, snowmelt, cooler temperatures, and new vegetation can create a temporary buffer against fire. In 2026, that buffer appears to have been much weaker. The landscape entered the warm season with dry soil, stressed vegetation, and fuels that were already behaving more like summer fuels than spring fuels. That is why the phrase fire season can be misleading. The calendar may say spring, but fuels respond to moisture, wind, and temperature rather than the date. The second driver was the failure of western snowpack. The source describes record low April 1st snowpack values across multiple western states, with California also near the bottom of its historical range. April 1st matters because it is close to the usual seasonal snowpack peak. After that point, the West generally shifts from accumulation to melt. Snowpack is not just mountain scenery. It is stored water that feeds rivers, reservoirs, soils, vegetation farms, cities, hydropower systems, and fire resistance through the warm season. When snowpack is low, the downstream effect is not immediate in every place. But the seasonal cushion becomes thinner almost everywhere connected to that water system. Lower snowpack can mean earlier vegetation drying. It can mean lower runoff, weaker soil moisture recharge, and less water available during the months when heat and fire risk usually peak. This does not automatically mean every western reservoir will fail. It does mean water managers and fire managers begin summer with less room for error. The third driver was a weak or incomplete green-up. In many grassland regions, spring green-up normally reduces fire danger because new vegetation contains more moisture, but when drought limits new growth, last year's dead grass remains more dominant. That creates a landscape with continuous fine fuel already prepared to burn. This is especially important across agricultural and grassland corridors. Wheat residue, pasture, grass, roadside ditches, and open prairie can become connected fuel beds. A forest fire may be visually larger, but a grass fire can move faster. In strong wind, the danger is speed rather than height. The fourth driver was atmospheric pressure and dry wind. Dry air, strong pressure gradients, and downslope or frontal winds can turn an already dry landscape into an active fire environment. The source notes humidity near 10% and gusts near 50 miles per hour in parts of the outbreak region. Those values matter because they exceed basic red flag thresholds by a wide margin. At very low humidity, fine fuels give up moisture to the air. When wind increases at the same time, flames spread, accelerates, and embers can travel ahead of the main front. That process creates spot fires. Spot fires are dangerous because they allow fire to leap over roads, fields, and containment lines that might slow it under calmer conditions. The fifth driver was resource timing. The National Fire System is designed around seasonal expectations, crew rotations, aircraft availability, and regional sharing. When elevated fire activity begins early, those assumptions become stressed. The system may still function, but it has to function longer and with fewer quiet weeks for recovery. A long season is not just a longer calendar. It means more deployment cycles, more maintenance demand, more fatigue, and more competition between regions if multiple outbreaks occur. That is why Level 2 in March or April means something different from Level 2 later in the year. It suggests the system is already spending energy before the traditional peak. The sixth driver was public attention lag. Technical agencies can see risk building through drought updates, snowpack readings, outlooks, and preparedness levels. The general public often sees risk only when flames, evacuations, or smoke appear. By then, the best preparation window may already be closing. That gap matters because fire prevention depends on early behavior. Farmers, utilities, drivers, counties, and homeowners make different decisions when they understand that the environment is already primed. One more driver is the way severe weather and fire weather can occur on opposite sides of the same system. The eastern side may receive thunderstorms, tornado warnings, and heavy rain, while the western side receives dry wind. To viewers, those can look like separate stories. Meteorologically, they may be connected through the same broad pattern. That is why one region can be dealing with severe storms, while another nearby region faces explosive fire danger. The same continental setup can deliver water to one side and remove moisture from the other. The important lesson is not that every weather system behaves this way. It is that spring volatility can create multiple hazards across neighboring regions at nearly the same time. The first real-world impact is power. Fire weather does not only threaten homes at the edge of a flame front. It also threatens transmission lines, distribution poles, substations, and repair access. A fire moving through a utility corridor can force difficult choices between keeping power flowing and reducing ignition or damage risk. For rural communities, electricity is often tied directly to water. Pumps, wells, pressure systems, and treatment equipment depend on power to keep water moving. That means a fire miles away can affect a household that never sees flames. If power is cut or infrastructure is damaged, the disruption can arrive through the tap. The second impact is air quality. Smoke from grassland and agricultural fires can travel far beyond the burn area when strong winds are already in place. This matters for cities and towns downwind. People with asthma, COPD, heart disease, older adults, children, and outdoor workers can feel the effects even when the fire is not local. The third impact is water quality. When fire burns through a watershed, it removes vegetation that normally holds soil in place. Later rainfall can wash ash, sediment, and debris into streams and reservoirs. That can increase treatment costs and create water management problems long after the smoke clears. The fourth impact is road access. In rural parts of the plains, one road can serve as both an evacuation route and an emergency response route. If fire crosses that road, the community problem changes immediately. Residents may have less time to leave, and responders may have less ability to enter. The fifth impact is agricultural stress. Fires in grasslands and wheat regions do not only burn open land. They can damage fencing, equipment stored hay, crop residue, livestock areas, and rural buildings. Even when acreage numbers look small compared with western forest fires, the local economic impact can be serious. The sixth impact is emergency management capacity. A tornado outbreak, a fire weather outbreak, a power disruption, and a smoke event can all demand attention from overlapping agencies. That overlap is one reason compound events are dangerous. The problem is not always that one hazard is unprecedented, but that several hazards compete for attention at once. This is where fact, inference, and interpretation should be separated. The confirmed facts include drought coverage, reported fires, red flag conditions, critical outlooks, and elevated preparedness. A reasonable inference is that the fire environment had been building before the headline event. The broader interpretation is that the United States is entering a season with less moisture buffer and more early operational pressure than normal. That interpretation should be framed carefully. It does not prove that every coming month will produce record fire activity. Weather can still shift. Repeated rainfall could reduce short-term danger in some regions, and local conditions will vary sharply from one county to another. But the evidence does support a cautious conclusion. The baseline risk at the start of the season is higher because several protective systems weakened at the same time. The public misunderstanding is often about scale. People hear wildfire and imagine forests, mountains, and remote western terrain. This event shows why grassland and agricultural fire deserve equal attention. Fast-moving plains fires may not look like crown fires, but they can outrun response, cross roads, threaten towns, and disrupt infrastructure quickly. Another misunderstanding is about rain. One storm can help, but one storm does not necessarily erase a seasonal drought. Soil moisture recovery requires enough precipitation over enough time, followed by conditions that do not immediately remove that moisture. If heat and wind return quickly, short-term improvement can fade. A third misunderstanding is about snowpack. Snow in the mountains may feel distant from a plains fire, but the systems are linked through water, soil moisture, vegetation, health, and seasonal drying. When mountain snowpack fails, the effect does not stay in the mountains. It moves through rivers, reservoirs, agriculture, ecosystems, and eventually the fire environment. The biggest meaning is that this is a preparedness story, not only a disaster story. The best time to understand fire risk is before flames define the map. That means knowing local evacuation routes, avoiding spark-producing activity during red flag warnings, watching air quality forecasts, and understanding how power and water systems connect to fire-prone corridors. It also means treating official outlooks as practical signals rather than background noise. For viewers, the takeaway should be measured but serious. This does not mean panic, but it does mean the margin for delay is smaller when drought, wind, fuels, and response pressure align. The 183 fire day was not the whole story. It was the moment a much larger story became visible. Before that report, drought had already expanded. Snowpack had already failed across key western states, and the national fire system had already moved into elevated readiness. That sequence changes the meaning of the event. It tells us the fire danger was not created by one afternoon of wind, but revealed by it. The lesson is not that every red flag warning becomes a disaster. The lesson is that when the land is already dry, the atmosphere needs less time to turn a spark into a moving front. This is the kind of pattern that deserves calm attention. It affects fire crews, utilities, water managers, farmers, rural residents, city air quality, and anyone living downwind of a dry landscape. The next updates will matter because they will show whether the drought footprint holds, expands, or eases. Until then, the most responsible reading is that the country has entered the warm season with less moisture protection than usual. If you value weather analysis that is clear, data-driven, and calm under pressure, stay with American Sky Brief. Subscribe and follow the signals with us because the next fire story may begin long before the first flame is ever reported.